All right, this is part two in this factoring quadratics series. So what we're going to go over in part two, well, in part one, we focused on A equals 1 and C is positive. We've covered both B being positive and negative in part one. In part two, we're still going to focus on A equals 1, but now we're going to focus on C is negative and B can be either positive or negative. Okay? All right, so I'm calling this case 3 and 4, by the way. They are essentially, quote unquote, the same. This is how I like to think about it, and this is how I'm teaching my students to think about it. Okay, let's think about the concepts. So actually, before that, let's quickly review the concepts that I wanted to impart in case 1 and 2. Remember, I was saying if you came from that video, because C is positive and the two numbers need to multiply to a positive number, that means both numbers must be positive or both numbers must be negative. And because the sum of the two numbers is positive, the two numbers have to be positive. Okay. And similarly, this one, the product of the two numbers is positive. So once again, they have to be both positive or both negative. And in this case, where b is less than 0, it's negative. So the two numbers have to sum up to a negative number. That means those two numbers must be negative. Okay. Well, that was the concept I wanted to impart. So the reason I say case 3 and 4 are pretty much the same is because when C is negative, the two numbers that we need to pick need to multiply to a negative number because C is negative. What's the only possibility? One of the numbers must be positive and the other must be negative. It has to be like that. No other choice. Yeah? That's why I say they are the same. Okay? Now, of those two numbers, if B is positive, the sum is positive. That means the positive number, remember I was saying one of them must be positive, one of them must be negative. The positive number is bigger in magnitude if B is positive. What does it mean to be bigger in magnitude? If you take the absolute value, which one's bigger? That's magnitude. Okay? Magnitude is the absolute value, basically. Okay? If you don't get that, I'll go over some examples and maybe that'll make more sense once you see it. All right. And and very similarly, if C is negative, once again, one number must be positive, one number must be negative because those two numbers need to multiply to a negative number. There's no other option. And if the sum of those two numbers is negative, that means the negative number is bigger in magnitude. Okay? We can keep that in mind to help us pick the numbers. But essentially, I'm saying case 3 and 4 are the same because the format is x plus some number, x minus some number for both these cases. One number must be positive, one number must be negative. Okay. All right, let's go through some examples now. So we have y equals x squared minus 3x minus 40. So we need two numbers. Again, the procedure is exactly the same. We need two numbers that multiply to negative 40. And those two numbers must add to positive 3. Okay. When it's one number that's positive, one number that's negative, in these cases, case 3 and 4, okay, there are a lot more options because, for example, we need two numbers that multiply to 40. We can have 1 and negative 40, but we could also have negative 1 and 40. You can flip the signs. Similarly, you can have 2 and negative 20, but you can also have negative 2 and 20, 4 and negative 10, and also negative 4 and 10. So there's basically twice as many options in this case. All right? The sign can be put on either one, the negative sign. All right. But we still have to reach the sum of negative 3. Okay. So we have to either go through all the possibilities or let's think a little more critically. Okay. This is why I was saying that magnitude stuff over here. Okay. The sum of those two numbers must be negative 3. Okay. If you think about it, when you sum up two numbers, one of them being negative, if the result is negative, that means the negative number is bigger in magnitude. Okay, so we can limit half the choices right away. Let's go through some examples, okay? So as I was saying, 2 and minus 20, when they multiply, they make negative 40, yeah? what's the sum of those two numbers? So 2 plus negative 20 or 2 minus 20, that's negative 18. So this isn't the right choice because we need negative 3. What happens if we swap the signs, okay? If we have minus 20 times 2, that's still negative 40, yeah? But negative 20 plus 2, sorry, did I say the right thing? Let me start over. What happens if we flip the signs? So negative 2 times 20, that would still be negative 40, yeah? But what if we had negative 2 plus 20? That would be a positive 18. We want a negative sum. So that's why I was saying the negative number should be bigger in magnitude. We take the absolute value of minus 20. That is positive 20, yeah? That's bigger than absolute value 2, which is 2. Okay, in the other case where I had negative 2 and 20, okay, the sum was positive because the positive 20 is bigger in magnitude. It makes sense. So take a minute or two to think about it. That makes sense. This will help you limit the choices, basically. Okay. So let's move on to the next candidate because 2 and 20 didn't work. Yeah. So how about 4 and negative 10? That makes negative 40. What's 4 plus negative 10? That's negative 6, not negative 3. So we got to keep moving to another possibility. How about 5 and negative 8? This should be, I probably copy pasted again. My bad. That's minus 40. And then 5 minus 8 is negative 3. That is what we want. So the two numbers are 5 and negative 8. So we write in factored form x plus 5, x minus 8. Okay, let's do another example. We have x squared plus x minus 30. The procedure is the exact same. We need two numbers that multiply to negative 30 and they add to positive 1. Okay, so let's help limit our choices again. This is positive, yeah? So the sum of those two numbers, one of them being negative, remember, must be a positive number, which means the positive number needs to be bigger in magnitude. Okay? So when we think of where to put the sign, we're going to put the sign on the smaller factor. All right? For example, 10 times negative 3, that's negative 30, yeah? 10 plus negative 3, that's 7. We got a positive sum. If you flip the sign to negative 10 and positive 3, the sum would be negative 7, which is not the right sign. So that's, again, I'm emphasizing that we can limit the choices if we figure out that since this is positive, the sum of those two numbers must be positive. So the positive number must be bigger in magnitude. Okay? All right. So 3 and 10 didn't work. What are some other factors for 30? How about 6 and 5? So 6 times negative 5 is negative 30, yeah. 6 plus negative 5 is 1. So that matches what we want. We want a plus 1. This gives us a 1, yeah. So the factor form is x plus 6, x minus 5. Right? Again, the takeaway tip, you limit the choices, figure out whether the positive factor or the negative factor is larger in magnitude. And how to do that, you look at the sign of this b. Okay. Example 3, y equals x squared minus 4x minus 32. Okay, so what two numbers multiply to negative 32 and add to negative 4? Okay, let's pretend we didn't take this tip at all. Okay, and let's choose 8 and 4. That makes 32, right? And then let's happen to choose that we want positive 8 and negative 4. Okay, that makes negative 32 when you take the product. And 8 plus negative 4 is 4. Oh, look, this is positive, but we want negative. So how can we make it negative? You just flip the sign of the two numbers that you chose. Okay? Hopefully this solidifies my previous point again. For, in this case, we want the sum of those two numbers to be negative. So you want the negative number to be bigger in magnitude. We want this 8 to be negative, not this 4. Okay? This 8, we want it to be negative because 8 is bigger in magnitude. Yeah? Hopefully it's solidified now. Okay, but let's pretend you just didn't take that tip, okay? And you got 4. Well, we can just make it negative by flipping the sign. So negative 8 times 4 is negative 32, yeah? And then negative 8 plus 4 is negative 4, which matches. So if you happen to get, the takeaway tip here is if you happen to get the opposite sign of the sum that you need, just flip the sign of the two numbers. Okay? And the factor form is x minus 8, x plus 4, by the way. Okay. Example 4. Y equals x squared plus 7x minus 60. So we want two numbers that multiply to negative 60 and add to 7. And we're going to take the tip where since that b term, that 7, is positive, we want the positive number to be larger in magnitude, okay? Now, instead of blindly choosing, because remember, let's go back to part 1 real quick. One of the tips was if the sum is too, not this one, sorry, this one. If the sum was too large, pick two numbers closer to each other. Sum's too small, pick numbers further from each other. We're going to do something very similar in this case, okay? Which example was that on? I was on this one, yeah? Okay. All right, so let's pick like 20 and 3. That makes 60, yeah? And then we know that the positive number should be larger in magnitude. So let's pick 20 and negative 3, okay? That makes negative 60 when we take the product. And then we add them. So 20 minus 3 is 17, okay? Here's the tip. 17, the sum of these two numbers was too big. Really, instead of sum, you can think of it as a difference because it's a subtraction, yeah? Up to you how you want to think of it. So I'm just saying that since the sum is too large, we need to get it smaller because we have 17, right? We want 7. How do we get this smaller? To get a difference between the two numbers that's smaller, this is a difference. That's why I put in parentheses. The sum is the difference because there's a minus sign, yeah? To get the difference between two numbers to be smaller, you need them closer to one another. That's how you make differences smaller. Think about it. 4 minus 2 is 2 versus 4 minus 0 is 4. 4 and 0 are further from each other, so the difference is larger. Yeah? 4 and 2 are closer, the difference is smaller. So here's that tip. This is too big. Yeah? So we need the difference of these two numbers to be smaller because we want from 17, we need to go down to 7. So we make those two numbers closer. All right? So next candidate, let's try 10 and negative 6. Okay? The product is minus 60, and then 10 plus negative 6, or 10 minus 6 is 4. Okay, so we moved in the right direction, but we overshot. We went from 17, we needed 7, but we went down to 4 now. Now, the sum or this difference between these two numbers is too small, so we need to make them further. So look, 20 and 3 are further from each other than 10 and 6, yeah? But now 10 and 6 are too close to each other. All right, so we want to pick something between 10 and 20. For example, 12. 12 times 5 is 60, yeah? So let's pick 12 and negative 5. Again, this positive number should be larger in magnitude. 12 times negative 5 is negative 60. 12 minus 5 is 7. Oh, that's what we want. So we factor as x plus 12, x minus 5. Okay, this is how we think critically instead of blindly choosing. Okay, we see that either the sum is too big or too small, or that really in these cases, the difference between the numbers is too big or too small. Okay, so we adjust it accordingly. We know that to get differences to be smaller, we pick the numbers closer to each other. To make the differences bigger, we pick them farther from each other, further from each other. Okay, so and that's what happened here. 20 and 3, too far, pick closer, so 10 and 6, right? This is too close now, so pick a little bit further, 12 and 5. Okay. Example 5. Y equals 4x squared minus 4x minus 8. Okay, so I thought we were focusing on a equals 1, but there's a 4 here, so we can't do this, or can we? We can, because we just need one additional step. We realize that 4 is a common factor of all three of these terms. Okay, so we can factor that out of all three of them. So we can write it as y equals 4 times in parentheses x squared minus x minus 2. I factored it out from all three terms. So if we distribute it back, you get back this, okay? Now this is a equals 1. We can factor it like before, okay? So we need two numbers that multiply to negative 2 and add to negative 1. What two numbers do that? Negative 2 and 1. So we can write it as 4 times x minus 2 times x plus 1. Okay, so once again, takeaway tip is if there's a common factor, between all three terms. Factor it out first so that you can make the numbers smaller. Okay, and then the subsequent factoring will be easier because the numbers are smaller. Okay, and this greatly helps when a is not equal to 1, like in this case. This is not even that big, but sometimes when you factor it out, you'll still have a term out in front that's not 1. We'll see that in part 3, okay? All right, another example, y equals negative x squared minus 3x plus 54. Hey, this is, again, not 1. This is negative 1. We can do the same thing as before. We can factor out a negative 1. You can factor out a 1 or a negative 1 from all terms. Okay, so when we factor it out, you get negative 1. I just wrote negative. In parentheses, we factor it out, so it would be positive x squared plus 3x minus 54. Okay, and then here we factor the inside of the parentheses like usual. We want two numbers that multiply to negative 54, and they add to 3. The two numbers would be 9 and negative 6. So we can write it as negative times x plus 9 times x minus 6. Okay, so I wanted to go through example 5 and 6 to start introducing that we can factor out a GCF first before we do this quadratic factoring to make our life a little easier. Okay, hopefully this was helpful. Stay tuned for part 3 where we go over more specifically in detail cases where a is not equal to 1. Hopefully I'll see you there. Bye.